Have you ever stood outside on a clear night and looked up at the stars, feeling that strange mix of awe and insignificance wash over you? It's a feeling as old as humanity itself, that humbling sense of wonder when faced with the sheer, incomprehensible scale of the universe. We're surrounded by cosmic mysteries every moment of our lives, yet most of us have only scratched the surface of what's truly out there. The universe isn't just vast, it's alive with phenomena so bizarre and breathtaking that they defy everything we think we know about reality. What if I told you that some of the most mind-bending facts about space aren't locked away in scientific journals or distant galaxies, but are hiding in plain sight, waiting for us to discover and marvel at them? That's exactly what we're diving into today. This video is your invitation to journey beyond the familiar, beyond the twinkling dots in the night sky, and explore 30 of the most surprising, astonishing, and downright unbelievable space facts that will completely reshape how you see the cosmos. We're talking about realities so strange they sound like science fiction, black holes that sing, planets where it rains glass, and stars so massive they make our sun look like a speck of dust. Each of these facts isn't just a piece of trivia, it's a doorway into a deeper understanding of the universe and our place within it. This isn't about memorizing numbers or dates, it's about awakening that childlike curiosity we all once had, that drive to look up and ask, what's really out there? So get comfortable, open your mind, and prepare to have it blown again and again. Whether you're a seasoned space enthusiast or someone who's just beginning to explore the wonders above, there's something here for everyone. We'll journey from the mind-boggling scale of nebulas to the eerie silence between stars, from the violent beauty of supernovas to the haunting mystery of dark matter. By the time we're done, you'll see the night sky not as a static painting, but as a dynamic, ever-changing story, one that we're all a small but meaningful part of. Let's begin. Our journey into the cosmos begins not in some distant galaxy, but with our closest celestial neighbor. Look up at the moon tonight, that familiar, glowing companion in the sky. It feels constant, eternal, a fixed part of our world, but the truth is far more dynamic. The moon is actually drifting away from us right now at a rate of about 3.8 centimeters every single year. That's roughly the same rate your fingernails grow. It's a slow, almost imperceptible migration, but over the vast stretches of cosmic time, it adds up to a profound change in the Earth-Moon relationship. This celestial dance is driven by the gravitational tug-of-war between Earth and the Moon, a phenomenon intricately linked to our ocean tides. The Moon's gravity pulls on our planet, causing the oceans to bulge slightly towards it. But because Earth rotates on its axis much faster than the Moon orbits us, our planet's spin actually drags that watery bulge ahead of the Moon. This leading mass of water, in turn, exerts its own slight gravitational pull, effectively tugging the Moon forward in its orbit. Giving it that extra nudge causes the Moon to spiral outward, moving into a progressively wider orbit. The implications of this gradual retreat are staggering to consider. In the distant past, the Moon was much closer. Imagine looking up and seeing a moon that appeared significantly larger, dominating the night sky. A day on Earth was also much shorter back then, lasting only about 18 hours because the moon's closer presence created stronger tidal friction that acted as a brake on our planet's rotation. As the moon continues to leave, it will continue to slow us down. Millions of years from now, Earth days will grow longer, and total solar eclipses, that breathtaking coincidence where the moon perfectly covers the sun, will become a thing of the past. The moon will appear too small in our sky to completely obscure the solar disk, turning those awe-inspiring total eclipses into partial and annular events. It's a humbling reminder that even the most seemingly permanent features of our heavens are part of an endless, evolving cosmic story. While the moon continues its slow retreat from our world, astronomers have discovered a planet so profoundly exotic that it challenges our very definition of what a world can be. Imagine a world not of rock and iron but of glittering crystal, a planet where the very ground beneath your feet, if you could stand on it, would be composed of diamond. This isn't science fiction, it's the reality of a distant exoplanet known as 55 Cancri e. Located a mere 40 light-years away in the constellation Cancer, this super-Earth orbits its star so closely that an entire year passes in just 18 hours. The surface temperatures are infernal, soaring to thousands of degrees, hot enough to melt iron and vaporize rock. But it's the planet's composition that is truly mind-boggling. Scientists believe the world is incredibly carbon-rich. Under the immense pressure and searing heat within its interior, that carbon is compressed into a crystalline structure, a diamond. Current models suggest this diamond core could make up a significant portion of the planet's interior, potentially forming a layer hundreds of miles thick. It's a colossal celestial gem, a testament to the universe's ability to create wonders beyond our wildest imaginations. Now, the inevitable question arises: what is this diamond planet worth? Trying to calculate its value is a fun, albeit ultimately pointless, exercise in cosmic economics. If we could somehow mine and retrieve it, a physical impossibility with our current technology. The sheer volume of diamond would be so astronomically vast that it would instantly make every diamond on Earth virtually worthless. The global diamond market, valued in the hundreds of billions of dollars, would collapse overnight. Its value lies not in its potential price tag, but in its existence as a natural marvel. 55 Cancri e stands as a stunning reminder that the universe is a place of infinite variety, where the very elements we treasure as rare luxuries on our world can form the bedrock of an entire planet light-years away. Leaving behind the glittering diamond world, we venture next to a planet often called Earth's twin, but one that has become a hellish vision of a runaway greenhouse effect. Venus, named for the Roman goddess of love and beauty, is in reality a crushing, scorching inferno, cloaked in clouds that rain acid. It's a world of such extreme and hostile conditions that it stands as a stark warning of how delicate a planet's climate can truly be. At first glance, Venus seems similar to our home. It's nearly the same size as Earth and has a similar rocky composition, but that's where the comparisons end. The surface temperature on Venus is a constant 860 degrees Fahrenheit, hot enough to melt lead. This is actually hotter than the surface of Mercury, even though Venus is nearly twice as far from the Sun. This counterintuitive fact is the result of a catastrophic greenhouse effect. The planet's incredibly thick atmosphere is almost entirely carbon dioxide, a potent greenhouse gas. This dense blanket traps the Sun's heat with terrifying efficiency, creating a surface pressure 92 times greater than Earth's, equivalent to the pressure you'd experience nearly 3,000 feet beneath our ocean. And then there are the clouds. Venus is perpetually shrouded in opaque yellow clouds, but these aren't made of water vapor like Earth's clouds. They're composed of sulfuric acid, a highly corrosive substance that would eat through metal and flesh with ease. These clouds do, in fact, produce rain, but the rain on Venus is a perpetual corrosive drizzle of sulfuric acid droplets. In a twist that almost seems cruel, this terrifying rain never actually reaches the ground. The surface is so incredibly hot that the acid rain evaporates long before it can hit the scorched rock, rising back into the clouds to condense and fall all over again. It's a nightmarish, eternal weather cycle on a planet that effectively sterilized itself. Venus shows us that a world can start with ingredients similar to our own, and through a devastating climatic chain reaction, become a permanent oven, a sobering reminder of the delicate balance that makes our own planet so rare and precious. If you think the weather on Venus is bizarre, just wait until you try to set a calendar. On our planet, the definitions of a day and a year are straightforward and deeply ingrained in our lives. A day is one rotation on our axis, and a year is one trip around the Sun. But Venus completely upends this cosmic convention. Astonishingly, a single day on Venus, the time it takes for the planet to complete one full rotation, is longer than an entire Venusian year. It takes 243 Earth days for Venus to spin around once, while it only takes 225 Earth days for it to complete its entire journey around the Sun. This means if you were standing on the scorching surface of Venus, which of course you couldn't be, you would celebrate your birthday before you even saw the Sun rise and set once. This incredibly slow rotation is made even stranger by its direction. Every planet in our solar system, with the sole exception of Uranus, rotates counterclockwise when viewed from above the North Pole. This is called prograde rotation. Venus, however, is the rebel of the planetary neighborhood. It rotates clockwise in what astronomers call a retrograde rotation. So on Venus, the Sun would rise in the west and set in the east, a complete reversal of what we experience on Earth. How did Venus end up with this topsy-turvy, sluggish spin? The leading theory among planetary scientists points to a violent and chaotic past. It's possible that in the early solar system, a colossal impact with a protoplanet or a massive object sent Venus spinning in the opposite direction. Think of it like striking a giant billiard ball almost head-on, but with a slight glancing blow. Such a monumental collision could have literally sent the planet spinning backwards. Alternatively, some models suggest that strong atmospheric tides and gravitational tugs from the Sun over billions of years could have gradually slowed its initial rotation to a crawl and eventually flipped it entirely. This peculiar rhythm means the relationship between time and the Sun is utterly alien there. You would experience just 2 sunrises over the entire course of your life if you lived to be 100 Venus years old. If you thought Venus had a monopoly on extreme weather, prepare to meet the true king of storms in our solar system. For over 350 years, a colossal, swirling vortex has been raging in the atmosphere of Jupiter, a tempest so vast it could swallow our entire planet whole. This is the Great Red Spot, a persistent high-pressure region and the single largest anticyclonic storm we have ever observed. It's a hurricane on a scale that defies human comprehension, a permanent feature on a gas giant that has no solid surface to break it apart. The sheer size of this storm is its most staggering characteristic. While it has been shrinking over the past century of observations, the Great Red Spot is still estimated to be roughly 10,000 miles across. To put that into perspective, Earth's diameter is just under 8,000 miles. This means you could fit our entire world comfortably inside this single, monstrous storm with room to spare. It spins counterclockwise in Jupiter's southern hemisphere, trapped between powerful jet streams that have kept it rotating for centuries. The winds that scream around its outer edges are unimaginably fierce, consistently reaching speeds of up to 270 miles per hour, and sometimes even exceeding 400 kilometers per hour. These aren't gusts, this is a constant, violent scream of wind that would instantly shred any spacecraft we dared to send into it. What fuels such an enduring cataclysm? Unlike storms on Earth, which are powered by solar heat and moisture from oceans and quickly dissipate when they hit land, the Great Red Spot has no such limitations. Jupiter is a world of pure gas and liquid metallic hydrogen, with no solid ground to disrupt the flow. Scientists believe the storm draws its energy from Jupiter's immense internal heat, left over from the planet's formation, which drives convection deep within its atmosphere. This creates powerful updrafts and downdrafts that constantly feed the storm, allowing it to pull material from below and maintain its furious spin. The distinctive red color is likely caused by chemical compounds being upwelled from deeper within Jupiter's atmosphere and altered by ultraviolet radiation from the Sun, perhaps involving complex sulfur or phosphorus compounds, though the exact recipe remains one of the planet's many secrets. Perhaps the most intriguing aspect of this legendary storm is its gradual transformation. Detailed observations dating back to the late 19th century show the Great Red Spot was once even larger, perhaps wide enough to fit 3 Earths across its diameter. It has been steadily shrinking and becoming more circular, and its color has intensified from a pale brick red to a deeper, more robust crimson in recent decades. Some planetary scientists speculate it could eventually vanish altogether within our lifetimes, while others believe it may stabilize at a smaller size. Whether it persists for another century or slowly fades away, its centuries-long rage serves as a breathtaking demonstration of the raw, untamed power that governs the other worlds in our cosmic neighborhood. While Jupiter's Great Red Spot showcases unimaginable power on a planetary scale, it is still a single feature within a single solar system. To truly begin to grasp the magnitude of the cosmos, we need to contemplate a number so vast it often feels more like a philosophical concept than a tangible reality. It is often said that there are more stars in the observable universe than there are grains of sand on all the beaches and all the deserts of our entire planet. This isn't just a poetic turn of phrase, it is a staggering scientific estimate that reveals the breathtaking emptiness and abundance of the universe simultaneously. Let's try to break down this astronomical comparison. First, consider the sand. If you've ever walked on a beach, you know that holding a single handful of sand means you're clutching countless tiny grains. Now try to mentally pile up every beach on every coastline around the world. Then add to that every grain of sand in every vast desert, from the Sahara to the Arabian Desert and beyond. Geologists and physicists have actually done the math on this. The total number of sand grains on Earth is estimated to be in the neighborhood of 7.5 times 10 to the 18th power, or 7 quintillion 500 quadrillion grains. That is a 7 followed by 18 zeros. It is a number so large it feels abstract. Now look up. Astronomers estimate there are roughly 100 to 200 billion galaxies in the observable universe alone. And our own Milky Way galaxy, which is fairly average, contains somewhere between 100 billion and 400 billion stars. If we take a conservative estimate and say there are 100 billion galaxies, each with 100 billion stars, we simply multiply those two numbers together. 100 billion times 100 billion is 10 sextillion stars. That is a 1 followed by 22 zeros. 10 sextillion stars versus 7 quintillion grains of sand. This means for every single grain of sand on our entire planet, there are over 10,000 stars shining in the cosmos. The scale is utterly incomprehensible to the human brain, which evolved to understand the number of fruits on a tree or tribespeople in a valley, not the contents of the entire universe. This immense number forces a profound shift in perspective. Our Sun is just one average star among this unimaginable multitude. Every star you can see on a clear night is merely our closest cosmic neighbor, a tiny fraction of what's actually out there. This fact transforms the night sky from a canopy of distant lights into a single, illuminated page in an infinite library of galaxies, reminding us that the universe's capacity for creation far exceeds anything we can ever hope to fully quantify or understand. But for all the incomprehensible scale of the cosmos, some of its most extreme phenomena are hidden within the tiniest of packages. We move now from the unimaginably vast to the unimaginably dense, to the cosmic ghosts of dead stars. When a massive star, one much larger than our Sun, reaches the end of its life, it doesn't fade away quietly. It goes out in the most violent explosion in the universe, a supernova. For a brief moment, a single dying star can outshine its entire host galaxy. And in the wake of that catastrophic blast, what remains is often not a quiet ember, but a bizarre and terrifying object, a neutron star. These stellar corpses are the ultimate expression of density in our universe. To understand what that truly means, try to picture this. Take a single sugar cube, the kind you might drop into your morning coffee. Now imagine that tiny cube of material, but instead of being made of sugar, it's a fragment of a neutron star. That 1 cubic centimeter of matter would not weigh a few grams. It would weigh approximately 1 billion tons here on Earth. The force of its gravity would be so intense that if you could somehow lower it to the planet's surface, it would slice through the crust and mantle as if they weren't even there, plunging relentlessly toward the center of the Earth. This incredible density is the result of gravity winning a total victory over matter itself. During a supernova, the outer layers of the star are blasted out into space, but the core is left behind, catastrophically collapsing under its own immense gravity. The force is so powerful that it smashes protons and electrons together, fusing them into neutrons. Everything that was once a vast, roiling ball of hot gas, a star that could have been millions of miles across, is crushed into a sphere no wider than a city, typically only about 12 miles in diameter. You could fit one comfortably inside the island of Manhattan, yet within that tiny sphere is packed the mass of up to 2 of our suns. The laws of physics are stretched to their absolute limit, creating a state of matter that simply cannot exist anywhere else. This incredible compression has another dramatic consequence. It revs up the star's rotation to dizzying speeds, like a figure skater pulling their arms in to spin faster. A star that might have rotated once every few weeks can suddenly be spinning hundreds of times every single second. Many neutron stars develop incredibly powerful magnetic fields, trillions of times stronger than Earth. As these rapidly spinning, highly magnetized objects whip through space, they become nature's most precise lighthouses. They beam out intense radiation from their magnetic poles, and if those beams are aligned so they sweep across Earth as the star rotates, we detect them as incredibly regular, rapid pulses of energy. We call these pulsing neutron stars pulsars, and their rhythmic ticking is so precise that it rivals atomic clocks. They are the universe's metronomes, the steady, beating hearts of long-dead stars, echoing their powerful final rhythm across the light years. But if you think neutron stars push the limits of reality, consider this. The most powerful telescope ever built by humanity allows us to do something that seems like pure magic. It lets us look back in time. This isn't a theoretical concept or a plot from a science fiction movie. It's the fundamental principle behind one of the Hubble Space Telescope's most profound capabilities. Because light, while incredibly fast, still takes time to travel across the vast emptiness of space. When you gaze up at the stars on a clear night, you aren't seeing them as they are right now. You're seeing them as they were. The light from our own sun takes 8 minutes to reach us, so we see it as it was 8 minutes ago. The light from the next closest star, Proxima Centauri, is over 4 years old by the time it hits our eyes. Hubble takes this simple, mind-bending fact and pushes it to the absolute extreme. By peering into the deepest, darkest patches of space areas that to earlier telescopes seemed completely empty, Hubble collects the ancient, faint light that has been traveling across the universe for billions of years. Its most famous effort in this regard is the Hubble Ultra Deep Field Image. To create it, astronomers pointed the telescope at a tiny, seemingly blank patch of sky for over 11 days straight, collecting every single photon of light that arrived. The patch of sky they chose was minuscule, equivalent to holding a grain of sand at arm's length against the heavens. What they found in that apparent nothingness was not empty darkness, but a breathtaking, crowded universe. The resulting image revealed a stunning tapestry of nearly 10,000 galaxies, each a colossal island of billions of stars, all crammed into that tiny pinprick of space. The true magic, however, lies in the age of that light. In that single image, we are not seeing a snapshot of the modern universe. We are looking at a deep time family photo album. Some of the faintest, reddest smudges in that image are galaxies as they appeared just 400 to 800 million years after the Big Bang itself. We are seeing them in their infancy, at a time when the universe was still young and primitive. This means that when you look at the Hubble ultra-deep field, you are not just looking across space, you are gazing back across 13 billion years of cosmic history, witnessing the formation of some of the very first structures in the cosmos. It is the closest thing we have to a time machine, providing direct visual evidence of the universe's evolution and confirming that galaxies grew and changed dramatically over billions of years. Every point of light in that image is a story, a history, and a testament to the fact that when we look out into the deepest void, we are ultimately looking back at our own origins. And just when you thought the cosmos couldn't get any stranger, it offers up a celestial cocktail on a truly staggering scale. Drifting through the void near the center of our Milky Way galaxy, there exists a vast, diffuse cloud known to astronomers as Sagittarius B2. This isn't a cloud of water vapor or simple dust. It is incredibly a gigantic cloud of gas that contains within it billions and billions of liters of alcohol. To be more precise, scientists have identified vast quantities of a compound called vinyl alcohol, along with other complex organic molecules. The sheer volume is almost impossible to visualize. If you were to somehow bottle it, it would create more alcoholic beverages than humanity has consumed in its entire history. So how does a cloud of alcohol spanning many light years across just appear floating in the vacuum of space? The answer lies in the delicate and complex chemistry that occurs within these interstellar molecular clouds. These clouds are often called the birthplaces of stars, and they are far from empty. They are immense, cold, and diffuse collections of gas, mostly hydrogen and microscopic dust grains. It is on the surfaces of these tiny, frozen dust particles that the magic happens. Over millions of years, individual atoms and simple molecules drifting through the cloud slowly stick to these cosmic specks of dust. The incredibly cold temperatures, often just a few degrees above absolute zero, make these grains act like tiny catalytic reactors, slowing down the atoms and allowing them to bump into each other, bond, and gradually form more and more complex molecules. Through this slow, patient process, simple carbon and oxygen atoms can eventually link up with hydrogen to form the building blocks of vinyl alcohol and other organic compounds. This process doesn't require life. It's a fundamental consequence of chemistry and physics playing out over astronomical timescales. The discovery of such complex molecules in Sagittarius B2 is profoundly significant. It tells us that the basic ingredients for chemistry that we associate with life are not unique to planets. They are being manufactured constantly throughout the galaxy, written into the very fabric of star-forming regions. This giant cloud of alcohol is more than just a cosmic curiosity. It is a powerful reminder that the universe is not only vast and violent, but also a sophisticated chemist, quietly assembling the pieces from which new stars, planets, and perhaps even the precursors to biology are born. While our own moon is slowly drifting away and Jupiter's storm rages on, other worlds are undergoing changes that are just as dramatic but far less visible. Let's turn our attention to the smallest and innermost planet of our solar system, Mercury. This scorched, airless world might seem like a static, ancient relic, but it is surprisingly active. Mercury is actually shrinking right now and has been for billions of years. This ongoing process has sculpted its surface in a uniquely dramatic way, creating some of the most striking geological features in our entire cosmic neighborhood. The reason for this planetary contraction lies deep within Mercury's core. Like Earth, Mercury has a metallic core, but proportionally, it's enormous, making up a staggering 85% of the planet's radius. For context, Earth's core is only about 50% of its radius. This massive iron core was once incredibly hot and entirely molten. But over the eons, as with any hot object left in the cold of space, it has been steadily cooling down. As the core cools, it solidifies, and most materials, including iron, take up less space as a solid than they do as a liquid. Think of it like a molten blob of metal slowly freezing and, in the process, tightening up and becoming more compact. This inward tightening of the planet's very heart pulls the entire world in on itself, causing the entire globe to contract. But a planet's brittle outer crust, its rocky shell, can't simply compress smoothly like a balloon deflating. Instead, as the planet's interior shrinks, the crust has to adjust to fit onto a smaller surface area. This creates immense compressional forces, and the solid rock has no choice but to fracture and break. Huge sections of the crust are thrust upwards and over one another, creating long, curving cliffs that can snake across the landscape for hundreds of miles. These features are called lobate scarps, and they are essentially giant thrust faults on a planetary scale. The word lobate comes from their curved, lobe-like appearance, and scarp is another word for a cliff or steep slope. Some of these scarps soar to heights of over a mile and extend for well over 600 miles, making them among the largest tectonic landforms we know of. A fantastic, simple analogy for this entire process is a grape slowly drying out and turning into a raisin. A grape has a soft, juicy interior. As it loses moisture and dries, the interior shrinks. The once smooth skin, now too large for the smaller fruit inside, has to wrinkle and fold upon itself to accommodate the new size. Mercury is that raisin. Its cooling core is the drying interior, and its crust is the wrinkling skin, forming the lobate scarps as it crumples. What's truly remarkable is that this isn't just ancient history. Data from NASA, a messenger spacecraft which orbited Mercury from 2011 to 2015, provided compelling evidence that this shrinking is geologically recent and may very well be ongoing today. The spacecraft identified small, fresh-looking cliffs and troughs that suggest the planet is still tectonically active, still creaking and groaning as it continues to cool down billions of years after its formation. This makes tiny, sun-baked Mercury a surprisingly dynamic world, offering a unique window into how terrestrial planets evolve and change long after their violent births. Those magnificent rings that make Saturn the jewel of our solar system, a symbol of cosmic beauty recognized by nearly everyone, are actually a fleeting feature. They are not a permanent part of the planet. They are more like a spectacular, temporary display of celestial fireworks. For a long time, astronomers assumed the rings were primordial, forming alongside Saturn over 4 billion years ago. But data from the Cassini spacecraft's final, daring orbits revealed a stunning truth. Saturn's rings are surprisingly young, likely only about 100 million years old. To put that in perspective, dinosaurs were still roaming the Earth when these rings first began to form, and they are not here to stay. They are currently in the process of disappearing, slowly raining themselves out of existence. This constant loss is driven by a complex interplay of forces. The rings are not solid. They are composed of countless individual particles of water ice, ranging in size from microscopic grains to chunks as large as houses. These particles orbit Saturn, but they are not in a perfect vacuum. They are bathed in radiation from the sun and subject to the planet's own magnetic field. This radiation can electrically charge the tiny ice particles. Once charged, these particles feel a pull from Saturn's magnetic field lines, which act like invisible highways that guide the ice inward, directly into the planet's upper atmosphere. Think of it like a slow-motion shower of ice crystals falling onto the gas giant. Cassini's instruments were even able to measure this ring rain, detecting the flow of water and organic compounds falling from the rings into Saturn's equatorial regions. The rate of this downpour is staggering. Estimates suggest this process drains an Olympic-sized swimming pool's worth of water from the rings every single day. At that rate, the entire ring system might be completely gone in another 100 million years, a mere blink of an eye in cosmic time. This revelation completely changes our understanding of Saturn. We are not looking at an ancient, static planet, but a dynamic system experiencing a spectacular, yet transient, phase in its multi-billion-year life. We are incredibly fortunate as a species to be living at just the right moment in cosmic history to witness this breathtaking ringed grandeur. Just when we think we have our own cosmic backyard mapped out, the solar system throws us another curveball. We've explored from the sun-scorched surface of Mercury to the icy realms of the Kuiper belt, yet there is compelling evidence suggesting a massive, unseen world is still lurking in the darkness far beyond Neptune. This isn't a rehash of the Pluto debate. This is the hunt for a true giant, a hypothetical behemoth astronomers refer to as Planet 9. The story begins not with a direct observation, but with a series of gravitational whispers. In the cold, distant reaches of our solar system, far past the orbit of Neptune, lies a field of icy debris known as the scattered disk. Here, objects like the dwarf planet Sedna follow incredibly long, elliptical orbits that take thousands of years to complete. The curious thing about the orbits of Sedna and several other of these extreme trans-Neptunian objects is that they are clustered together in a way that defies easy explanation. Their orbits are tilted similarly, and their closest approaches to the Sun, their perihelia, all point in roughly the same direction. For this to happen by random chance is statistically very unlikely, like rolling a dozen dice and having them all land on the same number multiple times in a row. This strange orbital alignment is the primary clue that points to the existence of a massive perturbing force. The leading theory is that the gravity of a large, undiscovered planet is shepherding these distant objects, shaping their paths through the solar system's outer darkness. Based on the observed effects, the hypothetical Planet 9 would be a true giant, a world with a mass estimated to be 5 to 10 times that of Earth. This would make it a mini Neptune or a super-Earth, a type of planet common throughout the galaxy but missing from our own local collection. Its orbit would be immense and highly elliptical, taking it on a 10,000 to 20,000 year journey around the Sun, never venturing closer than about 200 times the Earth-Sun distance and potentially swinging out as far as 600 or 800 times that distance. The search for this elusive world is one of the great modern astronomical detective stories. Confirming its existence is a monumental challenge because it would be incredibly faint, reflecting only tiny amounts of sunlight from such a vast distance, and its orbital path covers a truly enormous swath of the sky. Astronomers are using some of the world's most powerful telescopes, like the Subaru telescope in Hawaii, to meticulously scan the predicted regions of space where it might be hiding. They're looking for a slow-moving pinprick of light against the fixed backdrop of stars. It's a painstaking process, like searching for a single specific grain of sand on an entire beach, one handful at a time, and doing it all at night. The ongoing quest for Planet 9 is a thrilling reminder that our exploration of the solar system is far from over, and that major discoveries might still be waiting in the shadows, patiently orbiting just beyond our current line of sight. After exploring the distant and hypothetical Planet 9, it's humbling to turn our gaze back toward the heart of our own solar system, to the brilliant, life-giving star that rules it with absolute authority. We often think of the solar system as a collection of diverse worlds, rocky planets, gas giants, icy moons, and drifting comets. But in terms of raw physical presence, this diversity is little more than celestial confetti. The true solar system, the undeniable center of it all, is the Sun. To be precise, the Sun accounts for a staggering 99.86% of all the mass in our entire solar system. Every planet, every moon, every asteroid in the main belt, every icy body in the Kuiper belt, and every single comet combined makes up just a tiny fraction of the remaining 0.14%. To truly grasp what this means, let's try a simple thought experiment. Imagine a scale so vast it could weigh our entire cosmic neighborhood. On one side, you place our magnificent, glowing Sun. On the other side, you must pile up everything else. You start by adding Jupiter, the largest planet by far, which alone contains more than twice the mass of all the other planets combined. Then you add Saturn with its stunning rings, then all the rest: Earth, Venus, Mars, Mercury, Uranus, and Neptune. You throw in every single moon, from our own moon to Jupiter's Ganymede and Saturn's Titan. You keep adding, scooping up the entire asteroid belt between Mars and Jupiter, and then the vast, distant collection of icy objects beyond Neptune. You add every last speck of dust, every tiny pebble, and every distant comet wandering in from the Oort cloud. When you are finally done, the scale barely moves. The sun's side remains overwhelmingly, disproportionately heavy. All those worlds we find so fascinating are, in the grand tally of mass, little more than a rounding error. This incredible concentration of mass is the sole reason the solar system exists in its current form. Mass creates gravity, and the sun's gravity is the master conductor of a grand cosmic orchestra, dictating the motion of every single object within its immense sphere of influence. Every planet, from the swiftly orbiting Mercury to the slow, distant Neptune, is held in its elliptical path by the relentless, invisible tug of the sun's gravity. This force is what keeps Earth in the Goldilocks zone, at just the right distance for liquid water and life to exist. It's what captures comets into long, elliptical orbits and shepherds asteroids within the main belt. Even the hypothetical planet 9, if it exists, would be dancing to the sun's gravitational tune, albeit from an incredible distance. Without the sun's overwhelming dominance, there would be no solar system, just a chaotic cloud of disconnected objects drifting aimlessly through the void. This fact redefines our place in the universe not as the center of it, but as fortunate inhabitants of a tiny, well-ordered realm entirely dependent on the magnificent star at its center. This profound silence of space is one of its most fundamental and unsettling properties, a direct result of its true nature. Sound, as we experience it here on Earth, is a mechanical wave. It requires a medium to travel through, something with molecules that can vibrate and bump into each other, transmitting the energy of the wave from a source to our ears. Our atmosphere provides that perfect medium, a sea of nitrogen and oxygen molecules that carry everything from a whisper to a thunderclap. But space is, for all practical purposes, a perfect vacuum. It is emptiness, a void where atoms and molecules are so incredibly sparse that they are counted in mere handfuls per cubic meter. In such an environment, there is no medium for sound waves to propagate. The energy of a vibration has nothing to push against, no way to travel. So, even the most cataclysmic, energy-shattering events in the universe occur in utter, complete silence. Imagine witnessing the most violent explosion imaginable from a safe distance. A star going supernova, tearing itself apart with the force of 100 billion nuclear bombs. The visual spectacle would be overwhelming, a blinding flash of light that briefly outshines an entire galaxy. You would see the shockwave of energy and matter expanding outward at a significant fraction of the speed of light, a beautiful and terrifying cloud of stellar debris. But you would hear absolutely nothing. The silence would be as profound as the light show is brilliant. The same is true for any event in the void. Two galaxies colliding, asteroids smashing into each other, or a black hole shredding a star. All of these epic dramas would play out as the ultimate silent films. This presents an obvious and critical challenge for human exploration. How do astronauts communicate when there is no air to carry their voices? The solution is a brilliant technological workaround that bypasses the need for a medium altogether: radio waves. Radio waves are a form of electromagnetic radiation, just like visible light, and they can travel effortlessly through the vacuum of space. Inside their helmets, astronauts have small microphones that convert the sound waves of their speech into electrical signals. These signals are then transmitted via radio from antennas on their suits to antennas on the space station or spacecraft. The receiving antennas then convert those radio signals back into electrical signals, which are turned into sound waves by speakers inside the listener's helmet. This is why you hear the familiar crackle of the radio in every transmission from space. Their voices are literally riding on a beam of light across a short distance, a tiny bubble of human conversation surrounded by an infinite, soundless expanse. This stark reality is why almost every science fiction movie and television show gets it scientifically wrong, but for very good artistic reasons. From the roaring engines of the Millennium Falcon to the explosive pew-pew of laser cannons and the deep thrum of a starship's warp drive, filmmakers almost universally add sound to space battles and engine noise. This is a deliberate and necessary choice for dramatic effect. Our brains are wired to process our environment through a combination of senses, and sound provides crucial feedback about power, impact, and scale. A completely silent dogfight between spaceships, while accurate, would feel strangely flat, weightless, and emotionally disconnected to a viewer. The sound effects are not a mistake, they are a translation for our benefit. They take the silent, visual data of an event and interpret it into a sensory language we can intuitively understand and feel, heightening the tension, excitement, and visceral impact of the scene. So while the real cosmos is a silent symphony of light, the versions we enjoy on screen are a sonification, an artistic interpretation that gives a voice to the voiceless violence of the vacuum, making the unimaginable feel immediate and real. For centuries, Mars has captivated our imagination as the most Earth-like world in our solar system, a rusty red desert that seemed to hold the secrets of a lost world. The question of water has always been at the heart of that mystery, because where there is water, there is at least the potential for life as we know it. We now know with absolute certainty that Mars was not always the dry, frozen desert we see today. The evidence for a wetter past is written across its entire surface, a geological record of flowing rivers and standing oceans that has been painstakingly decoded by our robotic explorers. Perhaps the most compelling evidence comes from the landscape itself, visible from orbit. High-resolution cameras have revealed a planet scarred by the unmistakable signs of flowing water. We see vast, dried-up riverbeds that snake across the plains, complete with intricate tributary systems that look exactly like those carved by rivers on Earth. There are enormous canyons, like Valles Marineris, a gash in the planet's crust that dwarfs the Grand Canyon, which was likely carved by catastrophic floods. Most telling of all are the ancient shorelines, giant deltas where rivers once emptied into a large body of water, and what appear to be the remains of ocean basins, suggest that a significant portion of Mars's northern hemisphere was once covered by a vast ocean, potentially holding more water than our own Arctic Ocean. The Curiosity rover has even driven over these ancient streambeds, finding rounded pebbles that were clearly tumbled and smoothed by a long-vanished flow of water. Today, that surface water is gone, lost to space over billions of years as the planet's atmosphere thinned and its magnetic field weakened, but the water didn't all disappear. A significant amount remains locked away in the planet's polar ice caps. These brilliant white caps, visible from Earth-based telescopes, are a mixture of water ice and frozen carbon dioxide or dry ice. They grow and shrink with the Martian seasons, but they represent a massive reservoir of potential life-giving water. Furthermore, we have strong evidence that water isn't just at the poles. Several spacecraft have identified signs of what might be recurring slope linear, dark, narrow streaks that appear to flow down steep, warm slopes during the Martian summer and fade in the winter. The leading hypothesis is that these features are caused by briny water, water saturated with perchlorate salts that lower its freezing point, allowing it to remain liquid just long enough to trickle down a hillside before evaporating or refreezing. The most astonishing discovery, however, may be hidden deep beneath the surface. Using ground-penetrating radar from orbit, scientists have found evidence of what appear to be large subsurface lakes of liquid water. The most prominent is located about a mile below the South Polar ice cap, and it's estimated to be about 12 miles across. The conditions there are extreme, with immense pressure from the ice above and water that must be incredibly salty to remain liquid at temperatures far below zero. While the direct detection is still debated, the potential existence of these dark, secluded, watery environments is a game changer. They could be the closest analog we have to the subglacial lakes of Antarctica, which are known to host microbial life despite total isolation. This opens up a profound possibility. If life ever did arise on a warm, wet, early Mars, these deep aquifers could have served as a refuge, a place where Martian microbes might have retreated and could potentially still persist, eking out an existence in the dark, salty waters far from the hostile surface. The hunt for water on Mars has evolved from a question of the past to a thrilling investigation of the present, and with it, the enduring hope that we are not alone in the universe. But if you truly want to grasp the mind-bending physics of a neutron star, it's helpful to understand what it isn't. It exists in a category of extreme density that sits perfectly between two other cosmic phenomena, white dwarfs and black holes. Let's start with a white dwarf. This is the fate that awaits our own sun. When a star of low to medium mass dies, it doesn't explode. It gently puffs off its outer layers, leaving behind its incredibly dense, Earth-sized core. This core is a white dwarf. The matter inside is degenerate electron matter, meaning the electrons are packed so tightly they resist further compression through a quantum mechanical principle. A single teaspoon of white dwarf material would weigh about 5.5 tons here on Earth. That's roughly the weight of a large elephant compressed into a sugar cube. It's incredibly dense, but it's only the first step on the ladder of cosmic compression. Now, take that density and turn it up to 11. A neutron star forms when a much more massive star collapses in a supernova. The force of this implosion is so unimaginably powerful that it overcomes the electron degeneracy pressure holding a white dwarf apart. The gravity is so intense that it literally crushes atoms themselves. It forces the electrons and protons to merge, neutralizing their charge and transforming them into neutrons. This creates a sea of pure neutronium, a state of matter where the very concept of an atom, with its nucleus and orbiting electrons, ceases to exist. There is only the neutron. This is why a teaspoon of this material doesn't weigh 5 tons. It weighs 1 billion tons. The difference between a white dwarf and a neutron star is the difference between compressing a car into a cube and compressing Mount Everest into that same cube. And if you go one step further, you cross the final threshold into the realm of the ultimate gravitational monster, the black hole. If the collapsing stellar core is even more massive, the force of gravity wins its total victory. Not even the neutron degeneracy pressure can hold it back. The matter collapses into an infinitely dense point called a singularity, and its gravity becomes so strong that not even light can escape from a region around it, the event horizon. So, a white dwarf is matter compressed as far as the laws of quantum mechanics for electrons will allow. A neutron star is matter compressed as far as the laws for neutrons will allow. And a black hole is what happens when matter collapses beyond any known law of physics, creating a point of infinite density where our current understanding simply breaks down. A neutron star represents the last possible stable state of matter before the universe throws up its hands and creates a black hole. It's a common and breathtaking piece of cosmic trivia that the coldest known place in the natural universe is not on some distant, dark ice world, but is actually a cloud of gas and dust expanding rapidly through our own galaxy. This is the Boomerang Nebula, located about 5,000 light-years away, and it holds the record for the coldest natural object we've ever found. The temperature there plummets to a mere 1 degree Kelvin. That is just a single, solitary degree above absolute zero, the theoretical temperature where all atomic motion ceases. It is an unimaginable cold, far more frigid than the empty void of deep space itself, which averages a relatively balmy 2.7 Kelvin. The reason for this profound chill is the nebula itself. It's a pre-planetary nebula, a stage in the death of a star similar to our Sun. At its center, a dying star is expelling its outer layers at a staggering speed over 160 kilometers per second. This is much faster than usual for such an object. This incredibly rapid expansion acts like a cosmic version of the refrigerant in your air conditioner or the gas in a can of compressed air that gets cold when you spray it. As the gas expands outward into the vacuum of space, its molecules spread out and its temperature plummets dramatically, sucking the thermal energy right out of the surrounding region and creating this pocket of extreme cold. Yet, for all its cosmic grandeur, the Boomerang Nebula's record has been shattered not by another astronomical wonder, but by the ingenuity of humans right here on Earth. In laboratories around the world, physicists have performed what seems like magic, creating temperatures that make the Boomerang Nebula seem almost warm by comparison. Using advanced techniques like laser cooling and magnetic evaporative cooling, scientists can slow atoms down to a virtual standstill. They have achieved temperatures within a few billionths of a degree of absolute zero, a realm known as Bose-Einstein condensation. At these temperatures, matter begins to behave in ways that defy our everyday experience, with atoms losing their individual identities and merging into a single quantum wave, a superatom governed by the bizarre rules of quantum mechanics. So, while the universe naturally produces incredible cold in the death throes of stars, it is humanity that has mastered the cold, pushing the limits of temperature to create states of matter that simply cannot exist anywhere else in the cosmos. The coldest place we know of is not in the depths of interstellar space. It's in a highly specialized, carefully controlled laboratory, a testament to our relentless drive to explore and manipulate the fundamental laws of physics. But if you thought having one sun in your sky was normal, the universe is once again ready to surprise you. For a long time, scientists and science fiction writers alike dreamed of worlds with two suns, a concept made famous by Luke Skywalker's home planet of Tatooine. It turns out this iconic cinematic vision is absolutely real. We have discovered entire categories of planets that don't orbit a single star, but instead circle a pair of stars locked in a gravitational dance. These incredible worlds are known as circumbinary planets, and they exist in a constant state of celestial ballet. The most famous real-world example is the Kepler-16 system, located about 245 light-years away. Here, a Saturn-sized planet orbits not one but two stars. The stellar pair consists of a smaller, cooler orange star and an even smaller red dwarf star. They orbit each other closely, completing their mutual dance in about 41 days. Meanwhile, the planet Kepler-16b follows a wide, circular path around both of them. From the surface of this gas giant, which of course doesn't have a solid surface to stand on, you would see two distinct suns moving in a complex rhythm through the sky. Their light would combine and separate, creating an ever-changing pattern of light and shadow, with double sunrises and double sunsets painting the horizon. The existence of these planets was a huge surprise to astronomers. We initially thought the gravitational tug of war from two stars would be far too chaotic and violent to allow for the stable formation of planets or for their orbits to remain steady over billions of years. The discovery of Kepler-16b and others like it proved that planet formation is far more robust and adaptable than we ever imagined. The protoplanetary disk of dust and gas from which these planets form apparently can exist stably around a binary pair, allowing worlds to coalesce at a safe distance from the stellar turmoil. This discovery dramatically expanded the potential real estate for planets in our galaxy, as a huge percentage of stars are actually part of binary or multi-star systems. Finding planets in these environments means the number of possible worlds out there is even larger than we once dreamed. Life on such a world, if it could exist on a rocky moon orbiting a gas giant like Kepler-16b, would be a study in extremes. The length of a day would be unpredictable, with the two suns rising and setting at different times. There would be periods of constant daylight when both suns are in the sky, and moments of single or even double twilight. The climate would be incredibly complex, driven by the changing angles and combined heat of two different stars, and perhaps most strikingly, shadows would rarely be simple. Most of the time, you would cast two distinct shadows, each pointing in a slightly different direction as the light from each star hits you from a separate angle. It's a reality that seems lifted straight from the pages of science fiction, yet it's a confirmed part of our astonishingly diverse cosmos. While our own planet is geologically alive with shifting tectonic plates and rumbling earthquakes, our seemingly silent and static moon has its own hidden tremors. We tend to think of the moon as a cold, dead world, a place where major geological activity ceased billions of years ago. But Apollo astronauts left behind seismometers on the lunar surface, and the data they sent back revealed a surprising truth. The moon experiences its own version of earthquakes, aptly named moonquakes. These aren't just rare, faint tremors. Some are powerful enough to potentially pose a serious risk to future human habitats and long-term exploration. There are several different types of moonquakes, but the most powerful and intriguing are the deep moonquakes, occurring roughly 700 kilometers below the surface. These aren't caused by shifting tectonic plates, as the moon has no such system. Instead, they are almost entirely the work of Earth's relentless gravitational pull. You see, the moon isn't a perfect, rigid sphere. As it orbits our planet, Earth's gravity exerts a tidal force on it, literally stretching and flexing the lunar interior. This constant gravitational kneading builds up stress deep within the moon's structure, and when that stress is finally released, it results in a moonquake. It's a powerful demonstration that even from a distance of nearly 240,000 miles, our planet is still physically shaping its companion. The character of these quakes is what truly sets them apart from their terrestrial counterparts. While a major earthquake on Earth might last for a few tense minutes at most, a deep moonquake can continue for an astonishingly long time, sometimes vibrating for over 10 minutes. The reason for this marathon shaking lies in the moon's extremely dry and rigid composition. Earth's crust is water-logged and fractured, which actually dampens seismic waves. The water acts as a lubricant, and the countless cracks absorb the energy, causing the shaking to die down relatively quickly. The moon, however, is incredibly arid and brittle. Without water to absorb the energy, seismic waves simply ring through the rigid rock like a struck bell, echoing and reverberating for what feels like an eternity. This presents a critical engineering challenge for the future. Imagine designing a permanent lunar base, a structure meant to protect astronauts from the harsh vacuum of space and the extreme temperature swings. Now factor in the potential for the very ground beneath that base to shudder and shake for 10 minutes straight. A prolonged seismic event could fatigue materials, crack seals, damage life support systems, and collapse unstable terrain like the walls of lava tubes we might want to use for shelter. Understanding the timing, location, and intensity of these tidal moonquakes is therefore not just an academic exercise. It is absolutely vital for selecting safe building sites and for engineering structures that can withstand this unique and prolonged shaking. Our return to the moon isn't just about planting flags, it's about building a sustainable future there, and that means listening carefully to the hidden rumblings of our celestial neighbor. Yet for all the crowded vistas revealed by Hubble and the intricate dances of binary stars, the universe is not a uniformly populated expanse. It is, in fact, a cosmic tapestry woven with threads of immense structure and vast, shocking emptiness. One of the most profound examples of this emptiness is a region known as the Boötes Void, a spherical chunk of space so desperately empty it has been dubbed the Great Nothing. Located about 700 million light-years from Earth in the constellation of Boötes the Herdsman, this void is not just a small, dark patch. It is an incomprehensibly vast cavern, spanning a diameter of 330 million light-years. To put that staggering scale into perspective, if you placed our own Milky Way galaxy at one edge of the void, it would take light, the fastest thing in the universe, over 300 million years to travel straight across this emptiness to the other side. In a universe that seems to be teeming with galaxies, the Boötes void is a shocking anomaly. While a typical region of space that size should contain many thousands of galaxies, perhaps even up to 10,000, surveys of the Boötes void have found only a few dozen. That's not just sparse, it's virtually a cosmic desert. Imagine flying through this region in a starship. For millions upon millions of years, you would see nothing but utter blackness outside your viewports. No swirling galaxies, no distant nebulae, just the occasional, lonely island of stars passing by in the immense dark. The few galaxies that do call the void home are mostly clustered together in a few thin filaments, like a handful of tiny villages connected by single roads in the middle of an otherwise uninhabited continent the size of North America. How does such a monumental emptiness come to be? Astronomers have two leading theories, and both reshape our understanding of the universe's large-scale structure. The first and more traditional explanation is that it is the result of a smaller, natural process called hierarchical clustering, but on a gargantuan scale. As the universe evolved after the Big Bang, matter didn't just spread out evenly. It clumped together under gravity, first into stars, then galaxies, then clusters and superclusters of galaxies. In this process, the gravitational pull of these immense structures naturally empties out the spaces between them. The Boötes void could simply be the largest and most extreme example of this phenomenon, a supervoid that grew to an exceptional size as surrounding superclusters greedily pulled matter away from it over billions of years. The second theory is far more exotic and suggests the void might be the result of a collision between our universe and another, bubble universe in the wider multiverse. This idea stems from the inflationary model of the Big Bang, which suggests our entire cosmos is just one expanding bubble in a frothing sea of countless other universes. If two such bubbles had gently bumped into each other in the very early moments of creation, the energy of that collision could have transferred and effectively swept clean a vast region of space, pushing matter out and leaving behind the incredible emptiness we see today. While this is a more speculative idea, it highlights how studying these great voids isn't just about cataloging empty space. It's a direct investigation into the most fundamental forces and events that shaped all of reality. The Boötes void isn't just a hole, it's a fossil, a preserved relic from the universe's most ancient history, and its profound silence speaks volumes about the strange and structured cosmos we inhabit. While most planets in our solar system spin like tops as they orbit the Sun, with their axes of rotation roughly perpendicular to their orbital plane, one world has decided to do a complete barrel roll. Uranus is the solar system's oddball, a planet that orbits the Sun essentially lying on its side. Its axial tilt is a staggering 98 degrees, meaning its rotational axis is almost parallel to the plane of its orbit. This gives Uranus the distinct appearance of rolling around the Sun like a giant, pale blue marble, a motion utterly unique among the planets. This extreme orientation is almost certainly the result of a cataclysmic event in the distant past. The prevailing theory among planetary scientists is that a truly colossal collision occurred during the formation of the solar system. A protoplanet, perhaps twice the size of Earth, is thought to have smashed directly into the young Uranus. This was not a glancing blow, but a direct head-on impact of unimaginable force. Such a collision would have been powerful enough to knock the entire planet onto its side, completely redefining its poles and its relationship to the Sun. The force of the impact might also contribute to the planet's unusually cold interior and its peculiar magnetic field, which is both offset from its center and tilted at a bizarre angle. This violent birth story explains why Uranus is such an outlier, a world permanently tilted by a history of cosmic violence. This bizarre tilt has a profound and dramatic effect on the Uranian seasons, creating a cycle of light and dark more extreme than on any other planet. Imagine a world where the concept of a normal day and night barely applies for decades at a time. As Uranus makes its 84-year journey around the Sun, each pole takes a turn pointing almost directly at our star. For a period of 42 Earth years, one pole of Uranus is bathed in continuous, unending sunlight. The Sun would appear to circle the sky near the horizon, never rising high and never setting for an entire human lifetime. Meanwhile, the opposite pole is plunged into an equally long, frigid night of total darkness that also lasts for 42 years. Only during the brief periods when Uranus is at a right angle to the Sun, essentially at its equinoxes, does the planet experience a day-night cycle similar to what we know on Earth, with the Sun rising and setting roughly every 17 hours. This means that a single season on Uranus, from solstice to solstice, lasts for 21 years. The atmospheric dynamics on a world with such an extreme energy imbalance must be incredibly strange, with heat slowly and unevenly redistributing itself across the globe over these immense timescales. It's a climate system governed by patience on a scale we can scarcely comprehend, all dictated by a single, ancient impact that forever set this ice giant spinning on its side. This remarkable fact flips our cosmic perspective entirely on its head. We often feel dwarfed by the universe, humbled by the sheer number of stars in our galaxy. But consider this, right here on our own planet, the abundance of life is so staggering that it actually outnumbers the grandest feature of our cosmic home. Scientists estimate there are between 100 billion and 400 billion stars in our Milky Way galaxy. That is an almost incomprehensible number. Yet, when researchers undertook the monumental task of counting every single tree on Earth, from the sprawling Amazon rainforest to the solitary birch standing in a snowy field, they arrived at a figure that is an order of magnitude larger, approximately 3 trillion trees. That's a 3 followed by 12 zeros. Let that sink in for a moment. For every single star that lights up our galaxy, there are roughly 7 to 10 trees right here on our world. This isn't just a fun piece of trivia, it's a profound testament to the incredible, thriving density of life on our planet. Our world is not just a pale blue dot, it is a verdant, living gem, absolutely teeming with biological complexity. The Milky Way, for all its grandeur, is mostly empty space, a vast collection of stars separated by light years of nothingness. Earth, by contrast, is packed. From orbit, our planet's defining feature isn't its blue water or brown land. It's its greenness, the vibrant signature of a biosphere in full swing. This comparison also serves as a powerful reminder of our responsibility. Those 3 trillion trees are not a static number. It's a figure that is constantly changing, and sadly, for most of human history, it has been in decline. It's estimated that since the dawn of civilization, humanity has cut down nearly half of the trees that once existed on Earth. The fact that we still have 3 trillion is a testament to nature's resilience, but it also underscores the delicate balance we influence every day. Each star in the Milky Way will burn for billions of years, largely unaffected by our actions. But every tree is part of a fragile, interconnected system that supports all life, including our own. So the next time you look up at the starry sky, remember that the true marvel might not be the distant suns, but the countless, silent giants standing right here beside us, breathing life into our world. But for a true monument to planetary violence, we must leave Earth behind and travel to the red plains of Mars, home to the single largest volcano in the entire solar system. This is Olympus Mons, a shield volcano so staggeringly massive that it redefines the very meaning of the word mountain. To stand at its base is to be confronted with a structure that seems to defy logic, a gentle slope that rises so high it essentially punches through the Martian atmosphere. Olympus Mons stands nearly 22 kilometers, or about 13.6 miles tall. That is 2.5 times the height of Mount Everest above sea level. But its true awe isn't just in its height, it's in its immense footprint. The volcano stretches 600 kilometers or 370 miles across. To put that into a perspective we can grasp, the entire chain of the Hawaiian Islands, the largest volcanoes on Earth, could fit comfortably inside its base. The cliff that encircles its outer edge, a scarp created by ancient landslides, is in places over 6 kilometers high, itself a sheer wall taller than any mountain on our planet. So how did Mars, a planet only half the diameter of Earth, manage to create such an unimaginable geological titan? The answer lies in two key differences between the two worlds: gravity and tectonic activity. Mars has only about 38% of Earth's surface gravity. This means that for any given volume of molten rock or magma, the force pulling it back down toward the planet's center is much weaker. This lower gravity allows Martian volcanoes to support far more of their own weight without collapsing under their own immense pressure, enabling them to grow to extraordinary heights that would be physically impossible on our more massive world. The second, and perhaps even more critical factor, is the absence of plate tectonics on Mars. Earth's crust is a dynamic jigsaw puzzle of moving plates. As a hot spot of magma wells up from the mantle to create a volcano, the tectonic plate above it is constantly, albeit slowly, moving. This movement pulls the volcanic vent away from the magma source over time. The result is a chain of volcanoes like the Hawaiian Islands, where each individual volcano is born, lives its life, and becomes extinct as the plate carries it away from the hot spot. The Big Island of Hawaii is the current active site, but it will eventually move on, and a new island, Loihai, is already forming on the seafloor to take its place. Mars, however, is a one-plate planet. Its crust is a single, stationary lid. This means that when a hot spot of magma found a weak point in the Martian crust billions of years ago, it just kept pumping lava to the exact same spot for possibly hundreds of millions of years. There was no tectonic drift to pull the vent away. The lava simply piled up layer upon countless layer in the same location, building a volcanic edifice of such immense proportions that it became a permanent, defining feature of the planet itself. Olympus Mons isn't just a mountain, it is a geological record of a more active, volatile Mars, a testament to what a planet can build when it has the patience of billions of years and the right planetary conditions to never, ever move. But if you could step outside the airlock and take a deep breath of the vacuum, an impossible act that would of course be instantly fatal, your nose would be greeted by a scent that seems utterly out of place. Astronauts returning from spacewalks have consistently reported a strange and specific odor clinging to their suits and equipment once they're back inside the spacecraft and repressurized. They describe it as a combination of seared steak, hot metal, and the distinct, acrid fumes of a welding shop. It's a pungent, metallic, and almost gunpowder-like aroma that is, for all intents and purposes, the smell of space itself. This cosmic cologne doesn't originate from any one planet or star. It's the lingering signature of the universe's most violent and energetic processes. The primary source is believed to be polycyclic aromatic hydrocarbons, or PAR. These are complex, hardy molecules made of carbon and hydrogen arranged in ring-like structures, and they are found throughout the interstellar medium, floating in the vast clouds of gas and dust between the stars. They are essentially the soot of the cosmos, created in the furious, high-energy furnaces of dying stars. When a star reaches the end of its life in a supernova explosion, it doesn't just blast out simple elements, it forges and spews these complex organic compounds across the galaxy. The aroma astronauts detect is thought to be released when these pHs, which have settled on the surfaces of their suits and tools during their exposure to the vacuum, become energized. The hard vacuum of space itself is a pristine environment, but it's filled with high-energy radiation from our sun and other cosmic sources. This radiation vibrates and alters the compound. Then, when the astronauts repressurize the airlock, introducing oxygen to these previously inert particles, it triggers a reaction. The high-energy molecules essentially off gas, releasing their scent into the cabin air for the astronauts to smell. It's akin to the smell of hot metal. When you heat metal, you're energizing its atoms, which allows them to interact with the air and release that characteristic scent. In space, the radiation does the heating, and the oxygen in the airlock allows our olfactory senses to finally detect it. This bizarre sensory report transforms our understanding of the cosmos from a purely visual and theoretical experience into something almost tactile and intimate. Space isn't just a silent, cold void to be observed from a distance. It has a texture and a smell that clings to the explorers who venture out into it. It's the scent of stellar death and cosmic creation, the fragrance of a billion nuclear furnaces, all distilled into a familiar, almost mundane aroma that connects the grandest events in the universe to the simple, everyday experiences of a grilled dinner or a machine shop. It's a visceral, personal reminder that we are not just observers of the cosmos. We are literally bringing pieces of it back inside with us, and it smells like the aftermath of a celestial forge. While the scent of space offers a strangely familiar sensory connection to the cosmos, the conditions on some distant worlds are so utterly alien they defy any earthly comparison. Take, for instance, the exoplanet known as HD 189733b. This world, located 63 light-years away in the constellation Vulpecula, is the stuff of both scientific fascination and pure nightmare. It's a planet where the skies aren't just cloudy or stormy. They are a swirling, violent maelstrom of molten glass, falling not down but sideways in a perpetual, scorching hurricane. HD 189733b is an archetypal hot Jupiter, a gas giant that orbits precariously close to its parent star, so close, in fact, that its year is a mere 2.2 Earth days, and it is most likely tidally locked, meaning one side forever faces the star in perpetual, blazing daylight, while the other is trapped in an endless, somewhat cooler night. This extreme proximity creates a temperature gradient of unimaginable intensity. The day side broils at temperatures around 1,700 degrees Celsius, hot enough to melt iron and vaporize rock. It is this incredible heat that is the engine for the planet's horrific weather. The atmosphere of this world is not composed of benign gases like nitrogen or oxygen. Spectroscopic analysis has revealed it to be a hazy, turbulent brew rich in silicate particles, the same tiny bits of rock and mineral that form sand and glass here on Earth. On the day side of the planet, the ferocious heat vaporizes these silicates, turning them into a gaseous component of the searing atmosphere. But these particles don't stay vaporized for long. Powerful winds, generated by the extreme temperature difference between the day and night sides, race across the planet's surface. And when we say powerful, we are speaking on a scale that redefines the word. These winds scream at speeds exceeding 8,700 kilometers per hour, which is over 7 times the speed of sound. To put that into a terrifying perspective, the fastest winds ever recorded inside the most powerful tornado on Earth top out at about 500 kilometers per hour. The winds on this exoplanet are over 17 times faster. This is where the physics becomes both beautiful and terrifying. As these supersonic winds blast from the day side toward the cooler night side, the temperature plummets rapidly. The gaseous silicate particles carried within this atmospheric river suddenly cool, condensing directly from a vapor into a solid. But they don't have time to form delicate snowflakes or gentle raindrops. Instead, they solidify into countless microscopic shards of glass. And because the winds are still moving at thousands of kilometers per hour, these newly formed glass particles do not fall gently toward the ground. They are whipped sideways, hurled across the sky in a blinding horizontal shower. The entire planet is engulfed in a perpetual, abrasive sandblasting storm of molten glass, a tempest that would instantly shred any probe or spacecraft we could ever hope to send there. The visual spectacle from a safe distance would be both mesmerizing and horrifying. Scientists believe the silicate haze in the atmosphere scatters blue light, meaning the planet likely has a deep azure hue, a deceptively calm, deep ocean blue appearance that masks the raging, incinerating furnace that lies beneath. It is a world of brutal irony, a beautiful cerulean marble hiding a heart of fire and a sky full of flying razors. A stunning reminder that the universe is capable of crafting realms of both breathtaking beauty and unimaginable violence, often in the very same place. As we plan our return to the moon, not just for brief visits but for extended stays and the construction of permanent bases, we encounter a surprisingly complex and deeply human problem. What time is it? Here on Earth, our entire concept of time is built around the consistent rhythm of our planet's 24-hour rotation. But on the moon, that familiar rhythm falls apart. A single lunar day from one sunrise to the next lasts a staggering 29.5 Earth days. That's over 700 hours of continuous daylight, followed by an equally long, frigid night. This extreme cycle makes an Earth-based clock utterly useless for organizing daily life and scientific operations on the lunar surface. Imagine trying to schedule a meeting or a rover excursion using a watch that says it's noon for 2 straight weeks. The very idea of a day loses all meaning. This isn't just a logistical headache, it's a critical operational hurdle. Precision timing is the invisible backbone of modern technology, governing everything from GPS navigation and financial transactions to the handshake between spacecraft and ground control. On the moon, where multiple nations and private companies will soon be operating simultaneously, a shared, standardized time is not a luxury. It's an absolute necessity for safety and cooperation. Rovers from different countries need to avoid collisions, landers require perfectly synchronized descent trajectories, and astronauts coordinating a joint experiment need to be working from the exact same clock. Relying on individual mission control centers back on Earth, each using its own terrestrial time zone like GMT or EST, would introduce dangerous margins for error due to the slight but significant delay in communications. A signal takes about 1.3 seconds to travel to the moon and back, and in a critical situation, that delay could be catastrophic. The solution, therefore, is to create an entirely new timekeeping system for the moon itself, a lunar time zone. This is far more complex than simply setting a clock forward or back a few hours. The core of the challenge lies in Einstein's theory of relativity. Because of the moon's weaker gravitational field and its motion relative to Earth, time itself actually passes slightly faster on the moon than it does on our planet. The difference is tiny, about 56 microseconds per Earth day, but in the world of atomic clocks and ultra-precise navigation, those microseconds add up. If you didn't account for this relativistic effect, a navigation system on the moon using an Earth-based clock would be off by nearly 100 meters within just an hour, making it impossible to land accurately or map the surface in detail. So, the international scientific community, led by space agencies like NASA and the European Space Agency, is now actively working to define and implement a coordinated lunar time, or LTC. This won't be a simple time zone like Pacific Standard Time. It will be a complete, independent time standard, anchored by atomic clocks either on the lunar surface or in orbit around the moon. This new heartbeat for lunar activity will be synchronized with universal time on Earth, but it will continuously account for that relativistic drift, ensuring that every clock on every habitat, rover, and satellite is ticking in perfect, unwavering unison. Establishing lunar time is one of those foundational, almost philosophical steps that truly marks our transition from being visitors to the moon to becoming residents. It's about imposing a human sense of order on an alien world, building the first piece of the temporal infrastructure that will one day allow a bustling lunar society to function smoothly, all ticking to the rhythm of a clock we built for a world that is not our own. And just when you thought a diamond planet was the ultimate cosmic luxury, the universe reveals an even more spectacular gem. Circling in the vast darkness about 17 light-years away is a star that has, at the very end of its life, transformed into something almost unimaginable, a diamond of truly astronomical proportions. This is BPM 37093, more poetically known as Lucy, a white dwarf star that isn't just made of carbon, but has crystallized into a sphere of diamond larger than our entire planet. To understand how such a celestial jewel forms, we need to revisit the dramatic life cycle of a star. Lucy was once a star very similar to our own Sun, shining steadily by fusing hydrogen into helium in its core for billions of years. When it exhausted its hydrogen fuel, it swelled into a red giant, eventually puffing away its outer layers in a beautiful planetary nebula. What remained was its exposed, incredibly dense core, now classified as a white dwarf. This Earth-sized remnant is no longer generating energy through fusion. It's simply a dying ember, slowly radiating its leftover heat out into the cold of space over billions of years. The key to its diamond nature lies in its composition. This particular white dwarf is composed primarily of carbon, the very same element that makes up the diamonds in jewelry stores on Earth. And just like those Earth-bound gems, a diamond forms under conditions of immense pressure and heat. As the white dwarf cooled over eons, the carbon at its heart began to solidify. Under the crushing pressure of its own incredible gravity, this stellar corpse packs the mass of our Sun into an object only slightly larger than Earth. The carbon atoms were forced into a rigid, crystalline structure. The entire interior of the star, across a span of 4,000 kilometers, underwent a process of crystallization, effectively turning the core into a single, gargantuan diamond. The scale of this object is what truly defies belief. Imagine a gemstone so large you could place the entire continent of Asia on its surface and still have room to spare. If you could somehow mine and retrieve this cosmic diamond, a physical impossibility, its value would be a number so large it loses all meaning. It wouldn't just be priceless, its existence makes the very concept of value seem quaint. But its true worth isn't monetary. BPM 37093 is a breathtaking natural wonder, a testament to the universe's ability to forge beauty from the ashes of stellar death. It's a perfect, shimmering monument to the end of a star's life, a diamond as big as a world, silently orbiting through the eternal night. This incredible 8-minute delay for sunlight is more than just a scientific fact. It's a fundamental feature of our existence that redefines our connection to the cosmos. Every warm ray of sunshine that touches your skin, every sunbeam that lights up a room, actually left the surface of the Sun over 480 seconds ago. During that brief journey, that light has traveled across 93 million miles of empty space at the universe's ultimate speed limit, an astonishing 186,282 miles per second. If the Sun were to suddenly vanish at this very instant, a hypothetical event that physics says is impossible, we on Earth would not only continue to see it shining brightly in our sky, but we would also continue to orbit the point where it used to be, blissfully unaware of its disappearance for a full 8 minutes. We are, in a very real sense, always living slightly in the Sun's past. Now, take that concept and stretch it out across the mind-boggling distances between the stars, and you begin to unlock the true nature of the night sky as a grand cosmic time machine. The familiar constellations are not a current map of our galactic neighborhood. They are a historical collage. The light from the closest star system, Alpha Centauri, is over 4 years old by the time it reaches us. When you look at the bright star Betelgeuse in the constellation Orion, you are seeing it as it appeared around the year 620 AD. the light from the Andromeda Galaxy, the most distant object visible to the naked eye, began its journey 2.5 million years ago when early hominids were first crafting stone tools on the plains of Africa. Every direction we point a telescope offers a view into a different epoch of cosmic history. This creates a profound and almost philosophical perspective on astronomy. As we peer deeper into space with powerful observatories, we are not simply exploring the universe as it is now. We are conducting an archaeological dig across time itself. The brilliant young blue stars we observe in a distant nebula might have actually lived their short, violent lives and died in supernova millions of years ago. Their light is only just arriving to tell us the story of their birth. Conversely, a faint red galaxy at the very edge of the observable universe shows us a time when the cosmos was in its infancy, a snapshot of the universe's formative years. This means there is no such thing as a single, universal now. Our now on Earth is a unique moment, while for a hypothetical observer in a distant galaxy, their now includes a view of our planet's past. They might, in theory, be seeing dinosaurs roam the Earth if their technology were powerful enough. The sky above us is not a static painting but a living, evolving archive, and every star is a messenger from a different year, delivering news of events that transpired long before any human walked the Earth. But for all the mind-bending physics we've explored, from crystallizing stars to silent supernovas, perhaps the most profoundly strange idea is that our entire universe might have a perfect mirror image, a cosmic twin where everything, including the flow of time itself, is reversed. This isn't just science fiction, it's a serious, albeit highly speculative, hypothesis born from the deepest symmetries in particle physics. The concept is known as the CPT mirror universe, and it hinges on three fundamental reversals: charge, parity, and time. In this hypothetical twin of our cosmos, every particle would be replaced with its antiparticle, left and right would be swapped, and time would run backwards. From our perspective, such a universe would appear to be evolving from a state of high entropy or disorder toward a state of perfect order, completely inverting our everyday experience of cause and effect. The driving force behind this incredible idea is a fundamental principle in physics known as CPT symmetry. This is considered a sacred, unbreakable rule in the standard model of particle physics. It states that if you simultaneously reverse the charge of every particle, mirror its spatial coordinates, and reverse the direction of time, the laws of physics should remain absolutely unchanged. The universe should behave exactly the same way. This symmetry is so robust that it's woven into the very mathematics that describe every particle interaction we know. If CPT symmetry holds true, and every experiment to date suggests it does, then a universe that is our perfect CPT mirror must, by definition, be just as physically valid and possible as our own. This leads to a fascinating resolution for one of cosmology's greatest puzzles. Why did our universe begin in such a perfectly ordered, low-entropy state immediately after the Big Bang? The sheer statistical improbability of this initial condition has baffled scientists for decades. The CPT mirror universe theory offers an elegant, if trippy, solution. Imagine that the Big Bang wasn't a true beginning, but rather a moment of ultimate symmetry. On one side of this event, our universe expanded forward in time as we know it, evolving from order toward disorder. But on the other side, a mirror universe expanded backwards in time from our perspective. From the viewpoint of an observer in that universe, they would be moving forward in time from a low entropy beginning toward a high entropy future, while we would appear to be the ones living in reverse. The two universes would be perfect mirror images, together preserving the overall symmetry of physics and explaining the mysterious initial order of our cosmos without needing any special, one-off conditions. While this remains a speculative and highly theoretical idea, it's a powerful testament to the human drive to find elegant, symmetrical answers to the universe's deepest mysteries. It challenges our most basic intuitions about time, cause, and effect, suggesting that our experience of reality might be just one half of a far grander, more balanced cosmic picture. Whether such a mirror universe truly exists may be forever beyond our ability to observe or verify, but its possibility expands our imagination and reminds us that the ultimate truths of the cosmos may be far stranger and more beautiful than we can possibly conceive. And now we arrive at perhaps the most fundamentally mind-bending fact of all, a concept that reshapes our understanding of reality itself. The universe is not only expanding, but it is doing so at a rate that defies one of physics' most sacred rules. Distant galaxies are receding from us at velocities that actually exceed the speed of light. This seems like an impossible contradiction. For over a century, we've been told that nothing can travel faster than light. It's the universe's ultimate speed limit, the constant that underpins Einstein's theory of relativity. So how can entire galaxies be breaking this most fundamental of cosmic laws? The resolution to this paradox lies in a critical distinction that changes everything: the difference between moving through space and the expansion of space itself. Let's break this down. The speed of light limit, that 299,792,458 meters per second, applies specifically to any object or information traveling through the fabric of spacetime. A rocket ship, a beam of light, a radio wave, all of these are things moving within the universe, and they are all bound by this ultimate velocity. But the expansion of the universe is an entirely different phenomenon. It is not about things moving through space. It is about space itself stretching and growing, creating more universe between existing points. Imagine you have a rubber band and you mark two dots on it with a pen. Now, if you stretch that rubber band, the two dots move apart from each other. Did the dots themselves move across the rubber band? No. The material of the rubber band itself expanded, carrying the dots along with it. Now, imagine that rubber band can stretch at any rate you choose, even a rate that would mean the dots are separating faster than the speed of light. That is precisely what is happening on a cosmic scale. The galaxies are like the dots. They are more or less stationary within the framework of expanding space. It is the space between them that is being created, and that process has no known speed limit. This expansion isn't uniform or gentle, it's accelerating. This astonishing discovery, which earned the Nobel Prize in Physics in 2011, means that the rate at which the universe is stretching is actually increasing over time. The mysterious force behind this acceleration is dubbed dark energy, and it constitutes about 68% of all the energy in the cosmos. We don't know what it is, but we can see its effect. It acts as a kind of anti-gravity, pushing everything apart. The farther away a galaxy is from us, the more space there is between us, and therefore the faster that space can expand. Beyond a certain distance, known as the Hubble radius, the cumulative expansion of all that space results in a recession velocity that exceeds the speed of light. This means there is a cosmological horizon, a point beyond which we can never see or interact with those galaxies, not because they are too far away in a static sense, but because the space between us is widening faster than light can hope to bridge the gap. The implications of this are both profound and deeply isolating. It means that as the eons pass, the observable universe is actually shrinking from our perspective. Galaxies that are currently visible will one day be pushed beyond our horizon, their light eternally too slow to ever reach us again. Future astronomers in a far-flung era might look up at a night sky that is almost completely black, with every other galaxy having vanished from view, leaving only the stars of their own island galaxy. They would have no evidence for the Big Bang or an expanding universe. Their cosmos would appear static, lonely, and finite. This accelerating expansion, driven by dark energy, is the ultimate fate of our universe, leading to a cold, dark, and isolated end. It is the most powerful and humbling reminder that the cosmos operates by rules that are far stranger and more magnificent than our everyday intuition can possibly grasp. We've journeyed through a cosmos that constantly defies expectation, from a diamond planet and a world with glass rain to a storm so large it could swallow Earth whole. We've discovered that the universe is filled with the scent of seared steak and the silent echoes of unimaginable violence, that time passes differently on the moon, and that we are forever looking into the past every time we gaze at the stars. These are not just isolated curiosities, they are threads in a grand tapestry that reveals a universe far more dynamic, bizarre, and creative than we could ever have imagined from our tiny vantage point on this pale blue dot. Each of these facts does more than just surprise us, it fundamentally shifts our perspective. Understanding that there are more trees on Earth than stars in our galaxy redefines the preciousness of our own world. Realizing that Saturn's magnificent rings are a temporary display and that we are alive at the perfect moment to witness them instills a profound sense of cosmic privilege. Contemplating the Great Red Spot or the boiling volcanoes of Mars reminds us that our solar system is a place of immense and ongoing power, not a static museum exhibit. These revelations pull us out of our everyday concerns and invite us to see ourselves as part of a much larger, ongoing story, a story of constant change, of violent creation and beautiful destruction unfolding across billions of years. This journey through the wonders of space is just the beginning. The universe is an endless source of mystery, and every answer we find simply leads to more fascinating questions. Now we want to hear from you. Which of these facts completely rewired your brain? Was it the backward sunrise on Venus, the singing neutron star, or the chilling emptiness of the great nothing? Share your number one mind-blowing moment in the comments below. We read every single one and love seeing which cosmic truths resonate most with all of you. If your curiosity is now burning brighter than a supernova, you're in the right place. We're constantly exploring new mysteries and digging deeper into the science that helps us understand this incredible universe. To make sure you don't miss our next adventure among the stars, tap that subscribe button and ring the notification bell. Together, we'll keep looking up, wondering, and discovering the astonishing secrets waiting for us in the great beyond.